Good morning. My name is Edward Wasurum, the teacher in Edward's Academics. We'll be continuing from where we stopped the other time. In today's class, we are going to discuss about the normalization of time series data. We are going to look at how time series data are being normalized before they are used for any meaningful analysis. Recall in my previous class, I told you that time series data has three characteristics. They have circular trend or variability, they have seasonal variation, and they also have cyclical variation, which implies that time series data are stochastic in nature. Being stochastic, they are unstable in most of the time, and given the fact that time series data are unstable in most of the time, it implies that while using time series data, the researcher will be cautious of the fact that the time series data must be checked properly. So to normalize time series data, there are two ways of normalizing time series. There are many ways of normalizing time series data, but we are going to look at two main ways today. According to Hisebri in 1992, Hisebri believed that stochastic time series data will always be normalized through regression, whereas Bose and Jenkins in 1970 had initially recommended that time series data should be differenced to normalize them. So relying on these two instruments of regression and differentiation, we are going to subject time series data to this pre-estimation test before they will be used for any meaningful unit root test. The reason why we are doing this video, I'm doing this video this morning, is because too many researchers do not subject time series data to this procedure before they perform the unit root test. And most of the time, they assume that the time series data they are using has intercepts alone, whereas the time series data do have intercept and trend. And most of the time, they assume that it has intercept and trend, while it doesn't have intercept and trend. It only has intercept or none. So the significance of this class is to enable us know that the time series data we are using is expected to be subjected into this procedure before it can be used meaningfully. So to show you what I mean, this morning I will go to eView. To show you what I mean. eView 9, I'm using eView 9 because eView 9 to me is more reliable to some extent. eView 9 to me is what I use. Let me go to eView. This is my eView portal. Let me import the series. The series in my desktop. Look at this. This is my desktop. I'm working on deficit finance series. This is my desktop. I've just imported the series. This is my desktop. I'm working from 1981. I input my start date 1981. Yes, I link to external source, expand it because of my eye. Okay, basically this is my eView worksheet, and I want to perform a unit root test for interest rate, for instance. Okay, let me say I want to perform a unit root test for the first variable, which is the dependent variable. The dependent variable for this study is a GDPPC, which is gross domestic product per capita. So basically, given the fact that this particular variable is a loggable item, and I want to perform a unit root test for it, I'll go to quick I'll go to quick and I'll move on. But before we perform this unit 2 test, what we need to do is to actually check if the particular variable has an intercept or trend. So to regress before differencing, the researcher will go to quick, you go to estimate equation. Then you now type in GDPPC, you give a space, you type a C, constant, you give a space, you now type a trend. You are now regressing this GDP series on its constants and trend. So if you click OK without changing anything here, you will be exposed to a result that looks like this. These are more or less a least square result that enables you to know if the variable equation has a trend or intercept. Okay, given the fact that the constant and the trend results has probability values that are less than 5%. Recall that if you divide this coefficient by the standard error, you get the statistics. And also recall that there is an inverse relationship between the t-statistics and the probability value. When the t-statistics goes up, the p-value comes down. When the p-value goes up, the t-statistics comes down. Whenever time the t-statistics is above 2.34, the p-value gets lower. So basically, to infer the presence or the significance of this constant and trend, or to take decision concerning those two observations on a GDPPC variable, the researcher will dwell either on the probability value or on the t-statistics. And given the fact that this p-value are all less than 5%, the researcher will now conclude that this particular variable has both intercept and trend. Remember that constant is also an intercept, both intercept and trend. So given the fact that this particular variable has both intercept and trend, we have fulfilled one condition that is required to perform a unit 2 test. What is the condition? The condition is that you must regress the variable on its constant and trend. So having regressed the variable on its constant and trend, we have now realized that this variable has both constants and trend. So when we are going to do the unit food, we are going to select or tick an icon that has constant and trend. Then at that level, whatever decision that will be gotten from the unit 2 test will be reliable. So basically, this is how we decide if variable has a constant and trend. And this is the first condition for normalization of the time series data. In this regard, we are working on GDPPC. Okay, given the fact that you are after regressing, you are supposed to difference. Then I will go back to the EV work file. Having realized that this particular variable has both constant and trend, I'll go back to my EV work file. This is the variable I am working on. I'll go back to my EV work file. My variable is GDPPC. I'll go to quick again. I'll go to series statistics. I'll go to unit 2 text. Then you now log GDPPC. You close the bracket. You click OK. Once you click OK, the unit 2 test bar will come up this way. Given the fact that you had earlier gotten the result of the pre-regression, which told you that the variable has both trend and intercept, the next thing to be done is to tick here. Remember, I told you that the regression is necessary because it will enable you to perform the unit 2 test. So having gotten that particular result, we'll now click here. The essence of that result is to enable us to know what we are going to tick among these three. The fact that the variable has both intercept and trend, we tick this one. Had it been the variable do not have intercept but it has trend, I would have ticked this one. If the variable do not have intercept and trend, I will choose none. But since the variable has intercept and trend, I will choose this one. Okay. At this particular test for unit 2 bar, we are looking at it from the first phase, which is the level phase. If there is stability, we will move on. That will move on to estimate a long run result. But if there is no stability, we will perform the first difference, second difference until we get stability. At this other side, the last selection, we leave it at automatic selection. Let the system select for us. Many of the time I like using archaic information criterion, but let's leave it as sparse information as the system provided in default. So without changing anything here, we have too many types of unit 2 testing procedure. We have about 6 types of unit 2 testing procedure. We have the augmented Dickey-Fuller, Philippe-Heron, KPSS, which is also pronounced Kwiatkowski, Philip, Smith and Shine, Lloyd and Co. We have NG-Perron. The first 3 unit 2 tests, are mirror opposite of the second 3 unit 2 tests. So the null hypothesis of the first 3 unit 2 tests is different from the null hypothesis of the second unit 2 test. They are mirror opposite of each other. So without changing anything here, if you click OK, you get the unit 2 result like this. This is how the unit 2 result comes. This is the unit 2 result for GDPPC. And the null hypothesis is that GDPPC has a unit 2 test. Whereas the alternative hypothesis is that GDPPC do not have a unit 2 test. There is a Venus constant and linear trend, and automatically the system selected a maximum lag of 9. Okay, looking at this result, your attention should always go to the first phase. The first phase of the result is where your attention should go. If you look at this first phase of the result, we have the t-statistics, we also have the probability value. Whenever time the probability value of a unit 2 test is above 5%, it then means that the null hypothesis is accepted. Again, whenever time the p-value of a unit 2 test is more than 5%, it then means that the null hypothesis is accepted. What is null hypothesis? That the variable has a unit root, or it has a unit root problem. Alternatively, in absolute term, if the value of the t-statistics is less than the value of the critical value at 5%, then the null hypothesis will be accepted, and vice versa. So in this regard now, we have now been confirmed, or we have now validated our previous assertion that GDPC has a unit root problem. And since GDPC has a unit root problem, we are going to normalize the unit root problem before we can be able to use this data for any meaningful analysis. And this is what they call differencing. During differencing, a system works like that. The system works like this. This is what they call differencing. And one other thing that will be known during differencing is that the sample size are always adjusted. Because what differencing does is to remove those variables that are supposed to cause problem. Those variables that would have made the system not to be normal. That is what differencing does. If you observe, the data we use for this study is from 1981 to 2021. But let's look at the sample size that came out after estimation. The sample size that came out after estimation is from 1984 to 2021, which is 39 years observation. So basically, the system will adjust itself by removing those observations that are supposed to cause problem for the system. So given the fact that there is a unit root problem, we are supposed to go to first difference to normalize this particular problem. That is the normalization process we are talking about. So if you go to view, you go to unit root again, without changing anything here, you just tick the first difference. If you tick the first difference button, you click OK without changing anything, then it will now take you to another section like this. This is the second result. In this result, the sample size is adjusted to 1983. One other year is added back to the system. And the p-value is now 1%, which is 0.0103. And whenever time the p-value is less than 5%, the null hypothesis will be rejected. That means that this null hypothesis will now be rejected. GDPPC do not have a unit root problem. Alternatively, if the p statistics in absolute term is greater than the critical value at 5%, you also conclude that this particular hypothesis will be rejected. That means that this particular variable is now stationary after first differencing. It is after first differencing that this particular variable becomes stationary. And logically, we would now say the particular variable is integrated as order 1. Order 1 means that it is stationary after first differencing. Had it been that this particular variable was stationary at level, we would have said that the variable reverted to its mean. But given the fact that this particular variable became stationary after first differencing, the variable did not revert to its mean. Rather, it became stationary after first differencing. So this is how we do a unit root test, and this is also what we mean by differencing or normalizing time series data. So time series data are normalized this way. If you follow this procedure, I believe that whatever decision you are going to take will be in line with what is required. Econometrics is systematic, so we should be able to adhere to little principles before estimations. This is what we call pre-estimation test for a unit root test and how unit root test is being conducted. Thank you for staying tuned to this channel, and I believe that in subsequent time we'll have too many good things to come. God bless you.